The next section we look at is linear equations in two variables. So again, anything that you see or hear that is a linear equation, you got to think about what the word means. So again, we're concentrating on that word right there. And if you hear the word linear, this means that we're going to make a line. Now, in most circumstances, you're going to always have two variables in this linear equation, and we'll learn more about this in depth here coming up. But a lot of the times we want to turn or have our equation in something that looks like this form right here. And like I said, we'll learn more about this later on. But from what we want to look at is that it has a y and it has an x in the equation, and they're not next to each other or being multiplied. They're separate from each other. If there's any other variable in it, it can't be a linear equation. All right? And if either of the variables in my equation has an exponent, it is not a linear equation. So if we had y squared is equal to x plus 7, that's not a linear equation. If we had y equals x squared minus 9, that's not a linear equation. Again, because of that and that. And like I said previously, if they're multiplied together, so if we had xy equals 14, this is not. So all of these are not linear because my variables have either an exponent or being multiplied together. So what we're trying to find here in this section is the solutions to linear equations. And when you think about solutions, that means we're looking for the answers. And the answers in this case are ordered pairs. And we're going to find those ordered pairs and use them to actually graph the linear equations. So again, when we're talking about a linear pair, we're talking about an x and a y. And we know that my x's are always going to go right or left, and my y's are always going to go up or down. So this is our goal today, to find those solutions whenever we want. And most of the time, when we do these and we find our ordered pairs, we're going to make a graph and be able to graph this. So again, we're going to use a coordinate plane. So if you have graph paper, you need to start bringing it. And when you do this, make sure you show your little marks on your graph as we would show using graph paper. And again, you don't have to show all of the little slashes with numbers. Maybe you just do even numbers, but I want you to show something so you show me that you understand what the numbers are. Okay? When we do this now, there's different options for a linear equation. We could have a positive line. So a positive line is anything that's going in this general direction, from the bottom left to the top right. So even if it's a little shallow or not as steep, those would all be considered positive slopes. And again, we'll get into more about the slopes and everything in the future, meaning the next couple of days. But we just want to introduce what you could possibly make today when you do this. And then we could have negative slopes. So now we're going to go in the opposite direction. And again, it doesn't matter how steep it is or how shallow it is. But now we're looking at something from the top left to the bottom right. And then we could have two other possibilities. And the two other possibilities would be what I would call special situations. And those special situations are vertical lines and horizontal lines. So if you think about those two words right there, vertical means just like you would think in basketball or something about your vertical jump. So a vertical is how high you can go up or down in some situations. Some of us can't jump very high, so we go down. But it doesn't matter where it's at. It could be a positive, it could be a negative, but those would be vertical lines. And then my horizontal lines always go right or left. And again, it could be positive, it could be negative. And we'll talk more about that, like I said, in the future. I don't know if we'll get to it this week, but definitely next week. So from here then, they're going to ask you to find the solutions of a linear equation. And this is kind of what this first section's all about. So we're looking to find solutions. And the solutions then, if we took our answers, they would form one of these four lines that we're going to look for. So when they ask us to find solutions, you're going to pick a variable. It does not matter what variable you pick. You might pick the same variable every single time. You might try to pick the variable that's easier. What I mean by easier is if I had an example like we had over here, y equals x plus 4, I'm going to probably pick this x as my variable that I'm going to manipulate because it's with the numbers and the other variable is all by itself. But again, if you want to pick the y's, you can pick the y's every time. So we're going to pick one of the variables. From there, then, you're going to choose 3 coordinates for that variable. Now again, it does not matter what these 3 coordinates are. All right, I would stay consistent. Personally, I'm going to choose these 3 coordinates, and my 3 are probably always going to be -2, 0, and 2. But again, it's totally up to you. You can do 1, 2, 3 every single time. The only bad thing about doing 1, 2, 3 is sometimes then your graph would be really, or your points would be really close together, so your graph might not show exactly what you wanted. But again, it doesn't matter. Okay, I would realistically try to do 1 negative, 1 positive, and then 0 all the time. And I don't always use 0 because when I put 0 into the equation, it cancels things out and it's really, really easy. So I'm going to pick those 3 coordinates, and number 3, I'm going to make a table. So when I make this table now, I can do it 2 different ways. I can do a vertical table or I can do a horizontal table. All right, so if I get one of those 2 tables, it's going to look something like this. And again, totally up to you how you like it. Again, we kind of talked about this yesterday. I would probably choose this vertical style because when I put my 3 numbers in, I picked 0, -2, and 2. And I start making this table. After I get both of my coordinates in there, I can put parentheses around my numbers, and they would actually look like points. Where this one to me, or I mean ordered pairs, this one to me, when I do this, that to me doesn't look like an ordered pair, but again, that's totally up to you. So we're going to make a table. We're going to put the 3 numbers that we chose for the variable that we chose into that table. And then number 4, we're going to find the other variable. So whatever variable we don't have, we have to find that other one. So in our case, we're looking for the y's. All right, so how am I going to do this? I'm going to put, in my case, the x's into the equation and solve. So this is why we had to go through all the lessons of learning how to solve an equation, because we're basically going to use that knowledge now to draw or find graphs that we can draw. So in this case right here, I'm taking my equation, y equals x plus 4. And I have to take each one of the coordinates that I decided on and stick it in for my x, because we decided that it's going to be an x. So I'm going to take this -2 right here, and and I'm gonna stick it into that equation right there. So y equals -2 plus 4. And then I just look at it and I decide what the answer is. So I ask myself, what's -2 plus 4? And y is equal to 2. So that goes back into my table. And realistically now, I have an ordered pair. And from here, then from my table, in the end of this section, we would take each one of these and we would plot them on our coordinate plane, and then we'd get a line. But again now, I have to do this with all three of the numbers that I chose. So now I'm going to put 0 in for that x. And again, why do I like 0? Because anytime that I have 0 in the problem, it basically just cancels that x out, or whatever variable, and so y is equal to 4. And again, I get my second answer. And then last but not least, I take my 2, and I stick my 2 in there. So again, y equals 2 plus 4, and we get 6 for our last answer. Now, when we get into the graphing part, you need at least 3 points to make a graph on our coordinate plane. Sometimes they'll say 4 solutions in this section, but again, it doesn't matter what the actual directions say. Anytime that you're going to graph, you need at least 3, but you can do as many as you want. And remember, all of us could pick different numbers here in my x, and we would get our answers for our y, but when we would connect all of the dots on our coordinate plane, all of those ordered pairs would be on the line that we would make when we connected all of our dots. So it doesn't matter which ones you use. Like I said, I always use -2, 0, 2 because I like a negative, a positive, and I like 0. But again, you can use whatever you want. Okay? So let's try another one here. So again, we haven't gotten to the graphing part yet, but basically we're finding ways to get to the graph. And so we're going to use the information that we're looking or finding now, and we would use that information from our table to make our graph. And so the next problem that we want to look at is y equals 4x plus 3. So it changes a little bit because there's a number now in front of the x, unlike we had in our first example. So now we have a coefficient. But again, I'm going to make my table, and I'm going to choose -2, 0, and 2 again. If you want to do something else, again, no big deal. And I'm going to take each one of them and put them in there now. Remember, what does 4x mean? It means I'm taking 4 times whatever x is. And so that means I'm going to multiply, and then I'm going to add. Remember, we're going back to basically the order of operations. So, don't forget to show your work here. This will help you to learn how to do all this stuff a little bit better when you're showing your work. So 4 times -2, we get -8 plus 3, and all I'm doing now is simplify. So again, the order of operations says I have to do multiplication before I add. What's -8 then plus 3? We get -5, and that fills in my blank, and we would have our ordered pair. So then we go and we do it again. So we put 0, and again, why do I like 0? When I put 0 in there, it totally cancels it out. So I don't even really have to do the or show the work in this one. I just know that this is 3. And then last but not least, we put in our 2. So y equals 4 times 2, and then plus 3. So 4 times 2 is 8. 8 plus 3 is 11. Now this is again where I wouldn't go and use, like, for this example, I wouldn't use like 10 or even more than 10 or less than -10, because then your points, if you have to graph them, they might get off of your coordinate plane over here. All right. So again, just take your time following what it says and making sure that you get all of your points, and then to see where all of your points would be plotted. We'll show you that here in just a second. All right. So the next example that we want to do is we want to now find solutions and graph. So now we're basically doing the exact same thing, but we're just doing one more step, and that is to graph the actual points that we make. So the next one I want to look at is something like this. Y equals, let's make it a negative. Negative 2x minus 7, for instance. All right, so again, when you do this, don't forget that you're going to take negative 2 times x. But again, all I'm going to do is set up my table, make up my x's again. Now again, if you wanted to do the y's, you could make up your y's, but you're going to have to divide, and then it gets a little bit more complicated. So I'm just trying to show you ways to make it as simple as possible. So again, now I'm going to take each one of my numbers that I made up, and I'm going to stick it into my equation. So again, I'm going to show this. Now remember, negative 2 is x. That's not that negative 2. So we basically have 2 negative 2's in the problem. And then we just simplify. Negative 2 times negative 2 is positive 4. And 4, we bring down the minus 7. And then we just simplify again. What's 4 minus 7? So y is negative 3. We stick that in there, and this will become our first coordinate plane, or a coordinate that we'll put on our coordinate plane. Again, when I put 0 in, it totally cancels that out, so I'm left with negative 7. Again, that's why I like it. It's nice and easy. Okay? And then last but not least, we put in positive 2. And then we'll simplify it. So again, negative 2 times 2 is negative 4 minus 7. So we get negative 11 for my last y. And that's the last coordinate of my last ordered pair. So from here now, we're going to go to our graph paper. Again, I stress you having graph paper and using graph paper. Okay? It'll be the easiest way for you to plot these points. Trust me on this. Now again, when you do your ordered pairs, or your coordinate plane, make sure that you draw your x-axis and your y-axis. All right, make sure you have numbers on there. As you can see, my numbers kind of started to get erased here, but make sure that you at least show me some of the numbers so you can show that you know what the coordinates actually are. So we put our numbers on there. Make sure you use straight lines. So that's why the graph paper is needed. So then we come back and we use the points that we found in our table. The first point is negative 2, negative 3. So where do we go? Remember, the first coordinate's always my x, so I'm going to go left and right first, and then I'm going to go up and down. So if it's negative 2 and then negative 3, I find where those 2 points meet, and I put my first dot. And then the next point was 0, negative 7. So again, where do I go? I start at 0, I don't go anywhere, but then it says negative 7, so that tells me I got to go straight down, and it's right on that axis. And then last but not least, we have 2 and negative 11. So I find 2 to the right. Again, I always got to go right or left first, and then I go down 11, see where those 2 would actually meet, and put my dot. And then this is really important. Don't forget to use a ruler, and when you connect your dots so they are a straight line. And when I make my straight line, I want to extend that line quite a ways. And remember, it's a line, so I need to put arrows at the end of each side because I want to make sure that it goes on into infinity. So again, when we talked about making that table and somebody didn't use negative 2, 0, 2, let's say we use negative 1. Well, if you would have put your negative 1 into the equation, you should have found out that you got negative 5. So negative 1, negative 5, right? If we would have used 1, it looks like it would have been right around negative 9. I would assume it's probably exactly negative 9. My line just got off a little bit. So again, the solutions of a linear equation is when it is on that line for whatever equation is given. So all of these points are solutions. So I can go through and I can see those answers right there. But like this point right here is still a point. I would just have to realistically guess at where that is. To me, it probably looks at -1/2 and -6. But I'm just kind of guessing there, okay? That's why it's important to use a ruler and make a straight line, all right? The other thing that we want to look at real quick is to turn your book to page 376. On page 376 there, on the bottom portion of the page, they show different ways of drawing linear equations, okay? So again, they're emphasizing here the positive slope, which is in the first one, the negative slope, which is in the second one, and then another positive slope in the third. And then they're showing you examples underneath there of nonlinear equations. And notice the equations here. In the equations, the first one, it shows x squared, right? So that's what we had shown up on the board earlier. Notice anytime that you have something that's squared in your equation, in our example here it was an x, it's going to show a graph that looks like a U. This graph right here is called a parabola, all right? Nothing real major for you guys today, but just so you see it and know what it is in the future. And then notice the second one, or the one in the middle, the x is cubed. And if you notice the graph on this one, it kind of looks like an elongated snake. And then if you notice that the variable's on the bottom and makes a fraction, then you have another whole different kind of graph where it's split up into two. But notice every single time that it's non-linear, there's some kind of curve in it. So the biggest thing that you need to take away today when they talk about linear equations is that they're going to make a line. All right? So, again, take your time, put in the numbers into the equation and solving for the actual problem or the solution that you're looking for, and taking each one of those points then and plotting them on your coordinate plane, and then at the very end, if you're asked to graph it, to connect the dots. Just because you plot the points on the graph does not mean that you actually plotted the points, or the graphed it, sorry. You didn't actually graph it. So you got to make sure that you take your time and connect the dots, and then a little too light. There we go. So you got to make sure that you connect your dots and put the little arrows at the end of the line. All right? So if you got any questions, come in and see me.